Hi everyone, I welcome you all to this third video on this topic of how do you find the range no matter whatever is the function given to you with respect to your AS level syllabus. In the first video, we have already covered the concept around domain and range. Over there, we understood how to find domain and range in different kind of scenarios, and then what is the best way to find the range. In the second video, now that you are aware about how to find the range in the best possible way, I told you that there are three different ways in which you can express your range depending on if the minimum value is negative infinity, maximum value is positive infinity, or maybe let's say in the minimum and maximum there are no infinities written but a pure number is written. So how to express your range in that kind of case also. So given that you are aware about all this kind of concept, now it's right time to jump upon understanding how to draw a graph for different kind of a function, and then once the graph is in front of you, how you can utilize it to find the minimum and maximum points, and then eventually come up with your final answer. So yes, in this video, let's get started with the straight line graphs. Now the first question that should strike in your brain is that, hey Rohan, how can I sketch this straight line graphs under 5 to 10 seconds? Or as soon as possible. So my reply to you would be that you are supposed to directly find your y-intercept and the x-intercept. How do you find them? First of all, straight line functions are expressed in the format of mx plus c. So y-intercept basically means that when x value becomes 0, at that time what is the output? And that is why I've written that substitute x value is equal to 0 and find the value of f of x. So you can clearly see that your f of x will always come out to be c. So yeah, you are also aware about that in the straight line c is called as y-intercept. So finding y-intercept is straightforward. You can say that it is always equal to c. Then how do you find out your x-intercept? X-intercept is that value when your output becomes 0. So at which value of x your output becomes 0? So you are supposed to find x value when the function becomes 0. That is, just solve this equation when it is equal to 0 and find the x value. That x value is your x-intercept. Now once you are aware about both of these values, what is the next step? Very simple enough. Just draw your axis very roughly, you don't need to be accurate. Plot your y-intercept, x-intercept and simply connect them. Just draw a line that is passing from these 2 points. Roughly it should pass, and yeah, that is how the graph looks like. And the arrow just signifies that the graph can keep on continuing if it wants to. And based on that, there will be certain kind of a domain. Let's say if a domain lies between these two values. So of course, your graph will exist only between these 2 points. So that is one type of the domain, that between two x values, you are going to have your domain. What is the other format of the domain? Maybe let's say uh, there is a value given to you on the x-axis and they say that x is greater than that value. In that case, you will say that I need to focus upon this part of the graph where one value is over here, the other value is plus infinity. And then what is the other way of asking the domain? It will be x less than a particular value. So in that case, all the values to the left of that value will be part of your domain. So of course, the respective outputs lie in this particular line. So the least value is minus infinity, and this is your maximum value in that case. So in these three cases, how do you find your range? That is what I'm going to teach you. But I hope that you understood how to quickly draw your straight line graphs, and from that, uh, based on the domain, you can highlight the part of the graph. And once you're aware about the minimum and the maximum value, you already know from my second video of this playlist that how to express your specific range based on that. So yes, I'll write the first question over here for you. And remember that all the question that I'm going to write over here is just a random equation that comes up in my mind. And that is the best way to practice your range by yourself. How to do it? Randomly choose one equation for the straight line, say that it is a function, then put a domain next to that, and then find your y-intercept, x-intercept. Based on the domain, highlight a specific part of the graph, and then try to find the range. Then what do? You go to Desmos, do exactly the same thing, plot your equation with the domain, and then see if the y values are matching your range or not. If it is matching, your answer is correct, or else it is incorrect. And this is exactly what we are going to follow in all the upcoming videos. So to get started with, write something like find the range for the function, put any kind of random thing that comes to your mind. Let's say 2x minus 4, something like this. And you can say that for the domain, any domain that comes up to your brain, let's say x is less than equal to 4, something like this. This came up in my mind randomly. So now that I'm having a straight line and a respective domain, what should I do? Because I'm supposed to find the range, the first thing is to sketch the graph. How to sketch the graph? You are already aware about that. So my y-intercept is minus 4, and then if I do 2x minus 4 is equal to 0, my x value will be of course 2. So my x-intercept is 2, y-intercept is minus 4. I just have to connect these dots and form the straight line. So let's get that into the picture. So let me choose one good color. Yeah, let me choose this color. A random sketch of the axis, a rough sketch, not random. So yeah, minus 4 may be somewhere over here, and 2 may be somewhere over here. Just connect this and you are done. You can see it's a rough line, okay? And just for the sake of making your notes a bit beautiful, I am just going to use a different color over here. So this is how the graph is going to look like. Of course, draw the arrow so that you know that the graph can keep on going forever. Now, on the x-axis, just mark your 4. Okay, let's say maybe 4 is somewhere over here, and the respective output can be found over here. And because your domain is to the left side of the 4, like this, to the left side of the 4, what are the respective outputs on the graph? Just highlight that part. Of course, everything that is below this value is part of the output. Clearly, what is the minimum value? As you can see that the minimum output can go to negative infinity, that becomes your negative, the minimum value of the output. What is the maximum possible value? So because 4 is part of the domain, the respective output will also be part of the range. But what is that value? Just substitute your 4 into this x. 2 times 4 is 8. 8 minus 4 is 4. So of course this is 4. So what is your range in this case? Your range is f of x, or let me write it with a red color. Your range in this case is f of x can take all the values that are always less than or equal to 4. That will become your range. Okay, 4 is the maximum value, and everything below that can be the part of the output if this is the domain. So yes, this becomes your range finally. Please remember guys, there are multiple different techniques in which you can find the range of the functions, but in all the different kind of formats you will have to remember a lot of different things. But if you stick with the graphical approach, the graph will be in front of you, and based on the graph you have to find the range. Simple as that. And that is why this is my personal favorite technique that I always stick to. Okay, if you don't want to draw the graph, imagine the graph, and from the imagination you can write your answer, because of course this kind of question is only for 1 mark. But yeah, at the beginning you will have to do the practice, right? Practice the sketching of the graph. It will make a lot of things better for you in the future. Okay, not only for the range, but also in the upcoming topics that you will face in P3. But anyways, this was the answer that we've got. Let's try to compare this with my Desmos. So I need to write 2x minus 4 over here, and with the curly brackets I can also write my domain. X is less than equal to 4. Clearly I can say that the output value is 4, right? The output value is 4, and then everything less than that, it can keep on giving you the outputs, keep on giving you the output. There is no end to it. You can keep on going downwards. That is why we say that the output will always be less than equal to 4, and that becomes your range. So we also confirmed our answer. Now let's move on to the next question. Again a random question. Find the range for function f of x is equals to minus x plus 2, something like this, for for x greater than equal to, let's say, 3. Okay, a random question again I have made by myself. So I'll go ahead and try to draw the sketch with the similar kind of colors that I've used. I'll draw my axis, I'll find my x-intercept and y-intercept, and I plot it. So my y-intercept is plus 2, and if I put minus x plus 2 is equal to 0, my x has to be equal to 2. So my x-intercept is also 2, y-intercept is also 2. So let's plot it. Let's say this is y-intercept and this is x-intercept. Just connect the line. I'm going to connect the line with the green color. That is how you draw your graph very quickly. Of course, you just have to draw a rough graph. This is just for your notes purpose. I never make my notes attractive. But anyway, this is your graph. And your domain is x being greater than equal to 3. Okay, so where is 3? Okay, 3 is somewhere over here, let's say. Everything greater than 3 includes all these x values, and the respective output starts from this place and can forever go down. So the minimum output that a graph can give in this case is again negative infinity, and the output when x value is 3 will be the maximum possible value. So what is that value? Put 3 value as an input to your x. So minus 3 plus 2 of course becomes minus 1. So this value in this case is minus 1. Now is minus 1 part of your range? Yes, because 3 is the value which gave you minus 1, and 3 is part of the domain. So minus 1 will also be included as a part of your range. So in this case, very similar to what you have written over here, you will say that the outputs, that is f of x, that is nothing but the range, is always going to be either equal or less than minus 1. Simple as that. That becomes your answer. So if I come over here and plot the same thing, minus x plus 2 and x is less than equal to 3, minus x plus 2, oh sorry, x is greater than equal to 3, my bad. So you can see that the maximum output that your graph is giving you is minus 1, and everything after that it can keep on going forever down. And that is why the output values lies in between minus 1 and negative infinity. That is why we say that the minus 1 is the maximum possible value, and the least value it can go towards is minus infinity. So I hope that this question is also clear to you. Now let's move on to the next question. Find the range for f of x is equals to 3x minus 4 for x greater than, and this time not writing equal to, let's say greater than 0. That is the question. Now in this case, again, I'll create a rough plot. My x-intercept will be 4 by 3. So 4 by 3, you can utilize your calci and see where exactly that is going to be. So if I'm typing this in my calci, I am seeing that the value that I'm getting is 1.333 somewhere. Okay, so maybe I'm writing this 4 by 3 over here, 1.333. Now y-intercept is minus 4, so let's say minus 4 is over here. Connect the line or connect the dots to create the line. So this is the straight line graph, and the domain is x greater than 0. So of course x equal to 0 is over here. Everything to the right of the 0 is part of your domain. So the respective outputs that you need to highlight is from this point, and it can forever go up. There is no stop because all the values to the right side are part of domain. So the respective output will be part of range. So in this case, clearly you can see that minus 4 is the starting point, like that is the minimum point, and the maximum point is plus infinity. So how do you write your range in this case? You will say that your f of x is greater than minus 4. Why not equal to minus 4? Because of course minus 4 is not included in your range, because you got minus 4 as an output when x was equal to 0. But yes, because x equal to 0 is not possible, only we are just starting just after x equal to 0, just after that. So all the values that are above minus 4, just above minus 4, from that value all the way up to positive infinity, that is included. But minus 4 is not included, only because of that reason, because minus 4 was the output when x was equal to 0 and 0 was not part of the domain. So yes, this was the question. I hope even this has given you some kind of an idea. Now one last question I'll deal with, and after that, just like this, you can keep on practicing by yourself. Of course, I forgot to check this result, 3x minus 4, and x was greater than 0 this time. So you can see that at this point, minus 4 is there, and everything above minus 4 was part of your range. As you can see, everything above that is a part of your output. Of course, because when x was equal to 0, y was equals to minus 4 is not going to be part of the range because x was not part of the domain. Now after this, let's say I'm having find the range for f of x is equals to x plus 1 for minus 1 x less than equal to 1. So your x values are going to lie in between minus 1 and 1, such that minus 1 is going to be included in the domain and positive 1 is not included. In that case, let me draw the graph. As you can see, it becomes very easy once you are having graph in front of you. That is why graph is my favorite way. So y-intercept is plus 1 and the x-intercept will be equal to minus 1. So let me write minus 1 for the x-intercept and plus 1 for the y-intercept, and then let me draw the graph. So my graph is ready. Now the domain is, the least value of domain is minus 1, the maximum is positive 1. So minus 1 is something that I've already highlighted, plus 1 may be somewhere over here. So of course, when the x value was minus 1, the output is 0. I already know that. And when my x value will be equal to 1, the output is 2. So I can say that as my domain lies in between minus 1 and 1, at x equal to 1, the output is 2. And my graph lies in between this point and this point. And now, because I know that the minimum value is 0 and the maximum value is 2, as I explained in the second video of this playlist, your range is going to be lying between the minimum value, which is 0, and the maximum value, which is 2, and your function will lie exactly between that, and the less than sign will come over here. Now you got 0 as the output over here because x was equal to minus 1. Is x equal to minus 1 part of the domain? Yes. So 0 will be part of your range. And similarly, as x equal to 1 is not part of the domain, so 2 will not be part of your range, and that becomes your final answer over here. And now just to confirm this, I'll go to Desmos and plot it over here. So the equation was x plus 1 in between minus 1 and 1. Minus 1 and 1. So here is the output of the graph, which lies, the output lies in between 0, and of course the maximum value, as you can see, is approaching towards 2. And because 2 is not part of the output, that is why I cannot highlight it over here. But yeah, the output will lie in between 0 and 2, and that is exactly what we have written over here. And as you can see, 2 is not included. So yeah, I hope that this has given you some kind of an idea of how you can create your own question, your own domain for the straight line functions, then how to plot the graph, and just by looking at the graph, find the minimum and maximum, and based upon that you can give your final answer. Now in the upcoming video, I'll talk about the quadratic functions. So yeah, I'll see you over there, where once again, I'll tell you what is the quickest way in which you can sketch the graph, and from the graph, how you can identify the minimum and maximum point, and finally, find the range. Thank you so much.